So here we are, just going to talk to you a little bit about using TouchOSC, UDP receive and route, mainly about how route works, because what we do here works with all versions of OSC using the UDP receive object, which basically stands for Universal Data Packet, and breaks down the OSC messages into their correct components. So the thing to do, just to check this out, is if you go to the Hexler.net website for the TouchOSC stuff, if you go to configuration, then we can run through how you configure your TouchOSC device to work with your computer. Now, what I've got here is hopefully this already set up on my machine. So you're looking at the configuration page. If I move this down here and hit done, I'm back to the Beat Machine page, which is where this is one of the few sort of default layouts that TouchOSC comes with. You can obviously edit on the computer a whole new layout and then send that to your app on your Android or your iPhone, iPod, whatever, and it works. So you see a little circle at the bottom here. When I press that, we go into this TouchOSC mode, and the thing we need to do, once you can see it, jolly good, we're only interested in the top one, TouchOSC, but that number there has to correspond with the number of your the IP address of your machine. So if you go up to your airport, down to your network preferences, you can find out what number IP that your machine has been allocated, and in this case 192.168.0.6, which is the same as that one. So I can go back to this. Now if you need to change this, you have to go to the next page where you've got the enabled sign, and it's when you click on there, then you can just alter the host IP address there. We don't need to do that, so we can go down. I'm going to leave the outgoing port at 8,000, the incoming port at 9,000, which is the default, and the local IP address is not so important. As long as we've left enabled on, we're okay. So going back now to the other bits of this. Here's the layouts. You can use different layouts. There's a few that are already set up. As I said, we've just got it set up for Beat Machine as a default, but it doesn't matter what one you're using. And obviously, for this project, I think building your own is where it's at. So let's just go back to that main page. Now, as you can see here, just pull this down. This one's got two faders, two toggles, or a couple more, and then a whole bunch of pads. Now, I've got the outgoing port set to 8,000, so if I come over here, I need to set this to 8,000, simple as that. Now, if I want to see what's going on, there's two ways of doing it. I can do a print command, stick that to there, and then hopefully when I move one of these faders and then open the Mac window, then you'll see that it's printed the fader information up there, which is a good, useful way of doing it, because you can see the path quite clearly, /1 /1 /fader 2, and then the value. So you can either use that method, or one that I tend to use quite a lot myself is just to use a message box and then to connect it to the right output, which is which is literally just a kind of says what the message is doing. So I've got fader 1, fader 2, and then I've got all the buttons. So I want to break this out so that I can use this. In the second part of this tutorial, what we'll do is use OSC as a routing, so we can actually send this data out via the Max MSP bus to another door, for instance. But in this instance, we're just showing how route works. So let's go back to that fader. Now, when I press this, you can see that we get a distinct path here, and then when I do that one, we get a different one. So I can take this path, and the good thing about the route command, or the route object, should I say, is, let me just open it so its own description. The route object takes a message and tries to match its first argument to the route's object's own argument. Okay, so in other words, we can basically, if we've got this argument here, /1/fader2, then the next bit of data that comes with that will be sent out of that argument. So let's do that. So I'll take root, leave a space, /1/fader2, and that will be enough. So I'll just connect that to that. Now, this being a floating point means it needs a floating point number box, so I'll stick that on there like that. And now when I move this, then that's come out of there. Now the cool thing is I don't need multiple instances of root, because if I leave a space and then do /1/fader1, then I'll get a second option, and I'll create that one. Now we should see these two independent. Now obviously they're flashing between each other there, but on my screen, I'll do that still. I can move these two, and the message information is coming out loud and clear across there. Now I've also got these buttons, so push obviously can be used for on-off information, along with lots of other things, selecting things. So if I was going to create an on-off toggle type affair for this, I can do /1/push1. Now the information that's going to come out of there has got a 0 next to it, just to see whether or not an integer box is going to work with that, or whether it needs a that's fine. So there we go, I'm using that button, and that's just 1 or a 0. Now if I want to make sure that I've got this set so that I can toggle something on or off, it's that classic case now, simple algorithm you should all know by now, which is cell for select 1, so that it only lets 1 through, not zeros, and then I'll put a toggle on that. You know, toggle has 2 states, and then I'm going to put an LED under that. So now hopefully I'll toggle that, and that'll toggle on, and that'll toggle off. So I've got that, and I've got my faders. And there you go. So, and you can obviously break out the whole thing with that situation. You only need one root command for the whole thing. So, I hope that makes sense. See you next time when we talk about running this through OSC.